Today,
but we can hear the video.
About drone, we are going to speak about surveying a land with a drone, especially for IDP or refugee settings. For this purpose, you need a drone which is compatible for that. Below in the notes, you will have a link that shows all the models compatible for surveying.
الترجمة على اللغة العربية يا شباب.
An application installed in your smartphone, Pics for the capture. Again, below you will see the link for the application. And finally, you need the software that processes digital images and generates 3D spatial data. For example, Agisoft Metashape or X4D Mapper. I will use, for this case, Agisoft Metashape. This tutorial will be split in 3 phases: the preparatory work at home, field survey, and finally the digital image processing. Before going to the field, you need to install on your mobile phone the application related to your drone, that application for all the setting of your drone. Additionally, you need to install the mapping app Pics for the capture and register. Of course, you need to load all the battery for drone, for remote control, and for the mobile phone. In our case, I went with the mayor on the field. The mayor showed me the boundary for the plant camp. Home back with Google Earth or Global Mapper, I've identified the area. Once your field has been identified, you have to define the area where you want to fly. In this case, I decided to fly over this area, so I will have as well part of the river. And of course, I will have a big boundary around our site. Once the global area has been identified, you should measure the size of the area that you want to cover. In this case, we have below 520 meters on this side and around 800 meters on this side. Unfortunately, my drone is not going to be able to fly over the whole area in one single flight. I need to split the area into flights. At this point, I have to identify the best takeoff location. I have, for this case, 2 options, option A and option B. Option A is higher elevated, which is good, but very difficult to reach. It is in the forest, while option B, it's very easy to reach, but lower elevation. If I take off on place B, I will have to fly my drone in 2 flights. The first one will be around 400 north and 500 west. The second fly would be around 400 south and 500 west. At this point, I prepare all my material. I will make a test fly at home. I will load the takeoff point.
شباب الترجمة موجودة على اللغة العربية, please.
I may not identify the location once in the forest, and I can go on the field at the first occasion. Inform the authority before going into the field, eventually send them the fly plan. Ideally, you go on the field with some authority, with a policeman. The drone can be confiscated, or it can even be worse. You can be jailed if you are close to a military zone or close to army checkpoint. Everything has to be done very, very transparent. Inform as well your office about your plan, and be with some local people in case of need of translation. Find a clean take-up space, connect your drone to your mobile phone and open the application DJI 4 Go. At this point, your remote control should connect to the drone, your mobile phone should connect to the remote control, and you need to calibrate your drone in order to have a better flying precision. Once this is done, you can close the Dji Go4 application. You open your previously installed application Pics for the Captures. You have to define if you want an orthophoto only, a 3D model only, or both, and you choose accordingly the double grid or the simple grid icon. You wait a moment until the phones get the location automatically. Eventually, you press the icon to find your location on the map. If you have a phone connection, you might receive a background map. If there is no phone connection, the screen will be just blank. You draw your flying area. It's a rectangle, we know, 400 meters on the north and 500 meters on the west. And you check where is your starting point and your ending point. Your starting or ending point shouldn't be far from your location. You check as well the elevation. For 3D modeling, I like to fly between 300 and 400 meters. For 2D modeling, all depends on the resolution you need. The resolution you will achieve based on the elevation is always displayed on your phone. Once you have set up your flying path, you have to check all the details, elevation, size, and flying time. I know that my drone will not be able to fly more than 15 minutes. That's why I will not exceed 12 minutes of flying time. I still need some battery to come back. Once everything is fine and controlled, I click on Start, and the system will make a general check. If everything is fine, the flying path is going to be uploaded into the drone, and the drone will take off automatically and doing its job. Of course, I have speed up the video. During the flight, you have always to keep an eye on the phone and check the velocity. The velocity must be somehow constant between 30 and 40 or 50 kilometers per hour. If upstairs is too windy, the drone might not manage to continue the mission. The drone might have as well a software problem. You might have birds on the sky. You have always to keep an eye on the situation, and you have to be always very carefully. Once the first flight is over, the drone automatically lands. You change the battery. You select the new area on the same way, 400 on the south and 500 on the west. You uploaded the fly to the drone and you start the second and the last mission. Again, for this case, the same recommendations are important. Keep an eye on your mobile, keep an eye on the speed, keep an eye on the sky, and be always careful. At this point, the mission is over. You can pack your drone, go home, and start elaborating your pictures.
The first video is over. You could see how easy it is to fly a drone over an area. You just have to plan a little bit in advance, because it's very important to know exactly where to take off, because the drone has a very limited battery. And you have seen, if you want a 3D model, you should fly rather high. I fly between 300 and 400 meters, and these take time. And it's very important. I would like to stress on that you do everything very transparent. You have to inform the authorities, the police, your office, the mayor, whatever people are involved on this assessment, because drone might have been perceived as a spy tools, and you might be really in trouble. So far, I never had problem, but also I was always with some authority on the field. And if you manage to be transparent, then it shouldn't be a problem. I know that in Syria, you have drones and it's possible to fly. It's just matter to bring it in. At this point, if there is any question, I would like to answer the question. You have seen on the chat several links. Those are the links of the software. There is also a link where you can find the list of all supported drones with these Pix4D captures. It's important if you plan to buy a drone, to buy one drone that can be compatible with this system, because you are not able to fly manually a drone at this elevation. You will not see the drone anymore once it's at 300 meters. Clear?
Andre,
Yes.
I have a question for this. I saw you have programmed this drone. What language does it use? Is it Scratch?
There are two programs so far. There are two applications in the smartphone. One is DJI Go4, which is the application, a free application that links the drone to your mobile, links the mobile to the drone and to the remote control. It's free, it's in English. I'm pretty sure there must be also Arabic version of that, because they sell DJI everywhere. And the second application is this one where you plan the fly path. This is Pix4D capture. This is also free application for the phone. I'm not so sure. I don't think there is an Arabic version of that, but those applications are very easy and a user-friendly application with a minimum of base of English should be able to run it. So I can now start the second video. In the second video, we are going now to take the picture that the drone has collected, put the picture in the software called Agisoft Metashape. It's one of the many software that you can have. This software is a commercial software. You can have a trial version, or on the link, you can even find a place where you can find an open version of this software. And this software helps you to make the orthophoto and the digital elevation model. I will start the movie, hopefully, with no problem.
We can take our micro SD card from the drone. We can load all the imagery into the computer. We open Agisoft Metashape Pro, and we can add all the picture into the software. Now we can see that all the pictures are geometrically displayed, exactly how the drone was flying. So the drone was actually doing a good job. We have imported 194 pictures. It's a lot of pictures. And the next step would be to check the quality of those pictures. Select all the pictures, right-click on it, click on Image Quality, and OK. This process will take a long time. Once this process is over, below, you might see the details of each image. You see the quality. Quality value vary between 0 and 1. 1 is the best quality, and 0 is the bad quality. I would advise to delete all the picture that has quality below 0.6. If you keep a picture of bad quality, it might jeopardize the whole process. At this point, we have to change the coordinates system of our picture, especially if you plan to include ground point as a reference. You go on this icon, you click on it, and you choose the right coordinate system. For Switzerland, as you know, it is UTM 32 North. At this point, it might be a good idea to save your workspace and to continue with the workflow. You click on Workflow, Align Imagery. You can choose the accuracy. If you choose high accuracy, the computer will take all the resources and it will use the imagery as they are. If you go low, medium accuracy, it will be quicker. Choose advanced and put K point limit at 120,000. It gives a better result, and type point limit 0. If you want to know the details, you have to check the manual of the software. The alignment of those pictures will take a long time. Once the alignment is over, you will have a first representation of your area in 3D. At this point, we need to create the point cloud. You go to Workflow, Build Dense Cloud, and then you will have again the option for the quality. You can decide between medium, high, lowest, and ultra high. If you keep ultra high, the pictures are going to be used as they are. And of course, it will take a very long time. At this point, I will take medium, hoping that the result will be good enough for our task. Of course, you can as well go to advanced and change the depth filtering between disabled, mild, moderate, and aggressive. If your image has important small details, especially distinguished, choose mild depth filtering. If your image has not so many detail, you can choose aggressive depth filtering. If you uncheck the color of the pixel, the process will be quicker. You click OK, and the process will start. It might take a very long time if you choose very high accuracy. As you can see, the program has generated the point cloud, more than 12 million of points, and we have a visual representation of the point cloud. We can continue with our workflow. We go on Workflow, we click on Mesh, and we can build a mesh based on the dense cloud. For 3D, you have to choose the option 3D, and again, for the quality, you can choose face count, many faces or low faces. As usually, higher the quality, more time the computer will take. Once the calculation is over, you will see on the workspace the 3D model appearing. You can see the amount of faces that the computer has developed. You can move around and you can have a first idea about your 3D model. It is time to make the digital elevation model. You go to Workflow and you click on Digital Elevation Model. Select DEM, Digital Elevation Model. You have to check geographic type, projection. Be sure that the projection is the right one. The source data must be dense cloud. The rest you can keep as they are, or you can check the manual to get better knowledge about. You click OK, and the computer will start to process. This will take again a long time. Once this process is over, the digital elevation model is going to be displayed. Be aware that there is a big difference between digital elevation model and digital terrain model. The digital terrain model will show the surface of the soil, while the digital elevation model will show the highest point on your area. It means the roof of the houses, the peak of the trees. Drones with conventional camera produce digital elevation models. You can see displayed the resolution of your digital elevation model, which is much better than this one that you can achieve through the internet. At this point, we can produce the orthomosaic, the orthophoto. You go to Workflow, Build Orthomosaic, and click OK. Choose projection geographic. Be aware that you have the right projection. The parameter should be DEM, and the rest of the parameters you can leave as it is. Click OK. At this point, the activity with Agisoft Metashape Pro are finished. We have imported the picture. We have aligned the picture. We have created the dense cloud. For this project, it took 4 hours and 30 minutes. We have created the digital elevation model, and we have created the orthophoto. All this project took us more or less 5 to 6 hours in middle quality. Of course, if you would have chosen high or ultra high quality, the time would be much longer. Before exporting all those layers for further use, we have to check the quality of our job. We go to Tools, we go to Survey Statistic, and we wait a few minutes. Once the process is over, you will get this picture. This picture shows the overlapping of your images. The blue one is the area with most overlapping, more than 9, and is the area with higher quality. You have to save this picture for further use later in Global Mapper. At this point, you can export the layers. You can export the dense cloud. You click on the layer, right click and export dense cloud. The best extension for this is LAS, LiDAR extension, which is very well known by Global Mapper and most of the GIS software. You can export the digital elevation model, right click on the layer and export them. TIFF extension is a good one for further use. And finally, you can as well export the orthomosaic, the imagery. Export orthomosaic, EGPEG is fine. Be aware that all these exported files are geo-referenced. Once exported, you can close Agisoft Metashape and open Global Mapper.
I can't hear you.
Can you hear me now?
Yes, perfect.
So now we have seen to proceed to process all those pictures that we have received from the drone. It's a very easy task. The software made Agisoft Metashape, but also the other one, Pix4D, for example, they are very, very user-friendly. And of course, you can read the manual to get into all the details, but even without having written the manual, you will manage to develop easily an orthophoto and a digital terrain model. The issue is that while with the orthophoto, it's clear, you have just to open the orthophoto in AutoCAD or in any GIS software, so you don't need to do any change. With the digital elevation model, it is more complicated because for our refugees, for our sites, we usually work with the digital terrain model, which is actually the terrain. And if you do a flooding analysis or if you want to do the contour line, we need the terrain, but not the elevation. And this is the topic of the next video, where I will show how to convert a digital elevation model into a digital terrain model. I start the video. The last one. Second. And now I change again the sound. Can you hear the sound of the video?
Don't forget to share. You didn't share. You didn't share your screen from the bottom.
Okay. Can you hear the voice of the video? It's fine.
No. We can't hear the voice of the video. You should do your magic again.
Now can you hear?
Start the video, let's see.
Can you hear?
No. Or it's played but very low, I don't know. It's either your voice or the video.
And now?
No, we can't. So far and low.
Stop the video, stop sharing. Now I share again. I share again, I open now the video.
I believe it is something with the microphone settings all the time.
You mix. Now this one, and now?
So low.
Very low.
Yes. So change the settings as usual, as you did the last two videos.
Yes, it's not here maybe. Now?
No.
Now?
That the projection is
perfect.
For that, you go to Tools.
Go back to the beginning, please.
This part of the tutorial will show how to convert a digital elevation model into a digital terrain model, and as well how to integrate our digital elevation model into the SRTM elevation model that you can download from the internet. We open Global Mapper, and as a very first step, we check that the projection is the right one. For that, you go to Tools, Configures, Projection, and you check. I have 37, which is fine for Syria, but my area is Switzerland, so I have to put 32 north. This is essential at the very beginning. After that, we load into Global Mapper all the important layers that we have produced with Agisoft Metashape. This means we can load the orthophoto and the digital elevation model. You could as well load the point cloud if you intend to manipulate those points. It will not be topic of this presentation, the manipulation of the LiDAR points. Be aware that with the LiDAR points, you can as well in Global Mapper produce a digital elevation model or a digital terrain model. Here we have displayed our imagery of rather good resolution. As well, we have displayed our digital elevation model. First step would be to check the quality of this information. And for that, we need to load the previously saved statistic information picture. This picture is not georeferenced, unfortunately. That's why we have to manually georeference the picture. It is a very easy task in a Global Mapper. You need to find at least 3 reference points. Let's take this point here and this one. So those are the 2 points. We can add those points into the list. Point 1. We can take maybe this point here point. We add it, 0.2, and maybe one below this point here. I think it's this one. And we add it. Now we have 3 points, and this should be enough to georeference this picture. Yes, it is precisely georeferenced. As we know, the blue area has the highest overlapping. It means it has the better quality. And for our purpose, we consider only the blue area. You can cross-check this information looking at the orthophoto. If we look at the imagery of this part, for example, this house here in the middle, where we have high overlapping, the building is nice, it's square, and looks very, very real. If you go into the border, where we have bad overlapping, you can see pictures are much worse. You cannot use really this type of information. That's why it's important to crop out the good part of the imagery and to delete or not to consider the bad part of the imagery. We create a new layer, area feature, just selecting all the blue area. You don't need to be very, very precise. That's it. We call it good quality area, good quality area. It's a new layer called good area, good quality. That's it. Fine. Now we have created this new layer. We don't need the statistic picture anymore. Now we can crop the orthophoto first. The way to crop is to select first this new area. Then you click on orthophoto layer, right click, option, and cropping. And below, crop to currently selected polygon. And this is done. Same will apply for the DEM. For the DEM, for the DEM, we have the same information. The border, the quality is bad. In the center, the quality is much better. That's why we crop as well the DEM. So you select the good quality area. You click on DEM, you right click on it, option, cropping, crop to currently selected polygon, and we have it. Now we have displayed only the good part, the good quality part of our work. Fine. Now we can compare our orthophoto first with the Google Earth imagery. And let's see how it matched with the surrounding. We click on online data. We go on world imagery. We connect. Of course, you need internet connection. We put up this one. Okay, and we zoom in. We can see that our imagery produced with Metashape really match with the Google Earth imagery. It's really rather precise because we choose the right projection and we choose only the good part of the imagery. That's fine. At the same time, we have to check how our digital elevation model matched with the SRTM elevation model. We have this one, zoom out, and we download the SRTM worldwide elevation data. It is very difficult to judge the quality of the two models, but you can see how precise the elevation model done by the drone, it is compared to the elevation model of the internet. But now I would like to show you something interesting. If we take the profile from here to here, we see a big step. We have our drone model, the red line, and the free digital elevation model, the blue line, and in between we have almost 25 meters. A big difference. Let's take this point. Oops. Same here. We have blue line SRTM, almost 25-meter difference. What does it mean? It means that the absolute elevation of our model is much higher, around 25-meter higher than the digital elevation model of the internet. Why that? This happens because the absolute elevation of the drone is not very precise, and as far as I know, there is no mean to calibrate this elevation, unless you use ground point. If you use ground point, you increase the quality of the elevation of your model. But we have to eliminate this big discrepancy in the elevation. There is an easy way to do that. If we concentrate on our interested area where we are going to put our refugees, you have to insert 4 reference points, and we insert them not on a forest, on the top of the forest, but we insert them on the terrain. It means we insert our 4 points on the terrain. Let's say one could be here, point 1, new layer, of course. Point layer, 1 point here. We could put 1 point here. Point 2, same layer. We could put 1 point here. Point 3. Now we have to give to those 3 points the elevation based on our digital elevation model. How we proceed, we select the 3 points. We right-click on it, align measurement, apply elevation to selected features. Okay, now these 3 points receive the elevation. We open Excel file and we add here the elevation of each single point, starting from the digital elevation model of the drone. So point 1 would be, with the digitizer tool, 1259.14. Point 2 would be 1246.6. 1246.6. Point 3 would be 1242.3. 1242.3. Now we give to those points the elevation of the other elevation model from SRTM. Same process. We select the reference point. We select this time the SRTM worldwide elevation data. We right-click on the points and analysis measurement apply elevation. Now we replace the previous elevation with the new elevation value. And now it's time to check the elevation. And now we can read the elevation of the single point with the info tool. Point 1 1235.96. Now we see the difference. And we see the average. .11. So it means we have to decrease the global elevation of our digital elevation model of 26.11 meter. We select our digital elevation model, we right click on it, option, alter elevation value, minus 26.11 and apply. Okay, now we can see how it lies in relation to the SRTM. We can put that as well. Path profile. Still big step, 80 and 12 meter difference we have. Our digital elevation model is higher, 12 meter higher here. Let's see how it looks like here. We are 5 meter higher. And let's see here. And we are 7 meter higher. Let's go down of 7 meter. Then option, alter, minus 33. Let's see how it looks like now. Here we have 86 meters still. This is not a good place. Here looks fine. Looks fine. We have 5 meter lower. Let's see here. And here we are lower, 1 meter lower. So you can see it's almost impossible to exactly match the two layers together. We know that our digital elevation model has a better relative elevation, but generally the SRTM has a better absolute elevation. We keep it like that. It is important that our digital elevation model lies a little bit stiffer than the SRTM model. This is because if you do the water shedding analysis, the water will have to run into your system and not outside of your system, if you want to see if your site is going to be flood prone or not. Now it's time to weld these two systems. We select the area of good quality. We select the digital elevation model. We give the elevation to the area of good quality. Apply elevation, turn layer, fine. And now we have to weld the SRTM with this good quality area. So you select SRTM, option, feathering, feathering within the current selected polygons. Feather outside the polygon rather than inside, and OK. Now let's see how it looks. Same system. We take the path profile. I have to connect this one. Path profile. This looks good. This looks good. This is less good. This is difficult because there is houses, so it's not a digital terrain model. Where else can we check? Let's check here. This looks somehow good. Only 1 meter difference. Now we have joined the two digital terrain model, but now we have to convert the digital elevation model into a digital terrain model. I can do the contour line of this area just to show you how it will be the result. We do the contour line of 1 meter. You see here, for example, this single house has been identified from the system as a small mountains. In reality, this is a house and should disappear. That's why now we have to identify all the features that do not belong to the digital terrain model. And what are those features? Are houses, cars, and trees. While it's easy to identify houses, it is more difficult for the trees. Let's do an example with this house. We have to create a new area. Ideally, I took out the orthophoto. Create area, so flattering area, flattering. You create a new layer. Okay. Now, this layer does not have elevation. You have to give to that layer the elevation on the same way. You select, you right click on it, take out this one, you right click on it and analyze measurement. Apply elevation. Now, this area receive the elevation. At this point, you can ask to flatten this area, advanced feature creation option, terrain, flatten elevation. You can increase the resolution, 1 meter resolution, and this is flattened. Okay, now this area has been flattened, keeping a little bit the contour line of the surrounding. So if we do now the contour line of the new developed area, it looks a little bit different. Still 1 meter, 5 meter, 5 meter, 5 meter, and we crop on the visible data. You see, now we can take out this one, we can take this one. Now the house has not been considered anymore. You can do the same for all the other houses, including you can do the same for the forest. Let's assume I want to eliminate this forest here. I have to create an area around the forest, keeping in mind that the border of my area should touch the ground. If it doesn't touch the ground, it will not receive the right elevation. I include this building. along the road. Now I want to flatten all this area. Fine. Again, I have to activate my DEM. I have to give to this newly selected area the elevation. I select it, right-click on it, analyze measurement, apply elevation. I replace it. Fine. Now I have two figures. And again, I go to Advanced Creation Features and Terrain. Increase resolution and click on that. And now although this area has been flattened, if we will do the contour line of this area, it will look like that now. Contour line, 1 meter resolution, 5 meter, not big, limit on the visible data. Okay. Take out this one, take out this one, take out this one, and put the picture. Now you can see that the forest has not been kind of considered, except this tree maybe. So you can proceed with all the features. This might take a long time, but for Syria, we have less forest and few shelter. That's why it shouldn't be a problem. I have prepared in advance all the area that I would like to be flattened. It means I have identified all the trees and the sheltered houses that I don't want in my digital terrain model. I look for this shape file, which I called area to be flattened. Okay, I just give better visuality to this area. Maybe red. All these are our items that I want to be flattened. I have to cross-check that my DEM and SRTM are activated. I select all the area to be flattened. I right-click on it and I give the elevation. Apply elevation to selected features as usually from both terrain layers. 90 features received the elevation. At this point, I right-click again and I go to Advanced Feature Creation option, Terrain, manually, 1 meter resolution. Okay. If I did a good job, I should have the digital terrain model and we can verify when we do the contour line. Fine, all this area has been flattened. I uncheck. Now we can do the contour line. 1 meter equidistance, 5 meter resolution, need on it for the peak, and just what is all visible on the screen. I speed up the process. We can cross-check now how our contour lines look like. We see we have managed to make a rather nice digital terrain model. Of course, there are mistakes. For example, here it's obviously a mistake. We don't have a mountains, it's just a tree. And here as well. Here also we have a small mistake, but the rest seems to be fine. We can improve our digital terrain model when we identify the mistakes, like this one, for example, this one again. But that's the way how to proceed. Here also a mistake that we have done. That's the way to proceed if you want to do the digital terrain model. Once you have done the digital terrain model and you don't have too many mistakes, you can make a watershed analysis or a flooding analysis, which is really realistic. I hope you understood the principle behind, and thank you very much for watching and listening.
Yes, we can.
Yes, I can hear you.
3 videos are over. I hope that with this 3 video, I managed to show the process, how to make orthophoto and digital terrain model out of the drone. It is an easy process. It takes a long time, but it is worth. And if you consider that to have the same result with the total station or with the ground survey, it will take much more time, and of course it will cost much more. So that's why I strongly believe that the use of drones for site planner, it is very useful, very important, and finally very, very easy. And I give now time to you to ask some question if you have.
Thanks, Andrea. Again, thank you very much. That was incredibly informative and very valuable. I know personally I'll be watching those over and over again. Certainly as a site planner, I have no drone experience at all, and I found those videos very very informative and very very useful. So thank you very much, Andrea. It was very timely and very, very much appreciated. Thank you.
Thank you very much. I hope to see you all with the drone on the field one day. Thank you.